Welcome, ladies and gentlemen. I'm going to go over the notes for 7.3, and if you are a sophomore and you needed the notes, this is why I'm doing a recording here for you. Meanwhile, first period is here, and they're looking at me like I'm crazy. That's just the way it goes, okay? What we're going to be talking about in 7.3 is we're going to be talking about rational functions and asymptotes. You're going to become experts with asymptotes today, whether they're horizontal or vertical, and then how you can use that to graph rational functions. And then we'll talk about how to use a table on your graphing calculators to be able to do all of that information. So let's go with some things that you've already done in 7.1. In 7.1, you already learned how to graph a parent function of 1 over x. When you had to memorize and you had to graph y equals 1 over x, I'm hoping you remember what that graph looked like. Let's say I had a line and it went down. Let me just draw here what that graph looked like. Do you remember memorizing this graph that looked like this? It was going to the right forever and ever, and it went up forever and ever. It went to the left forever and ever. It went down forever and ever. And it was kind of trapped by a couple of asymptotes. Asymptotes were things or boundary lines that the graph approached. Well, we're going to give that an actual definition this time around. We're going to actually say what an asymptote is. But before we do that, let's look at this graph and let's show where those asymptotes are. The asymptote for 1 over x had a vertical asymptote. Let me do that in red. The vertical asymptote was at x equals 0. The horizontal asymptote was at y equals 0, and they're both labeled here for you. We're going to be really hitting on what is an asymptote and why it's an asymptote, and you're going to have to find the vertical and horizontal asymptotes of graphs. So just to make a definition as clear as I possibly can. Your book defines an asymptote. This is an asymptote because it's a vertical asymptote because the function approaches positive infinity as it gets closer. As x gets closer and closer and closer to this value of 0, this graph gets closer and closer to infinity. It just gets bigger and bigger and bigger. From the other side, as I get closer and closer, as x gets closer and closer to 0 from the negative side, the y value gets closer and closer to negative infinity. As functions approach negative and positive infinity, that's where you're going to find an asymptote. And that's how it is for a vertical asymptote. If the y values approach infinity, it is a vertical asymptote. If the x values approach infinity, then it is a horizontal asymptote. So that's the way you can tell the vertical asymptotes apart from the horizontal asymptotes by the graph. So that's where we begin. We begin our whole ideas here based off of what does the graph look like. And then, as you get better with it, you will transition to knowing by what the equation looks like, what the graph is going to look like. So here's where I want to begin. Now that we've talked about that, let's do 4 practice problems. On your whiteboards in class, flip them over. Get to the graph paper. I want you to use the 4 quadrants of your graph paper. See how there's 4 quadrants, quadrant 1, 2, 3, 4. Make your own XY graph on each of the 4 quadrants. So you have basically something like this. You're going to make a graph over here. You're going to make a graph over here, an X and a Y. Here's your X and a Y. Here's your X and a Y. You're going to make 4 different graphs. 4 different graphs. You're going to be graphing f of x, You're going to be graphing g of x, graphing h of x, and graphing j of x. Now, when you do this, I want you to practice plugging this into your graphing calculators. So let's make sure, let me zoom in here on these two questions so you can kind of see which the equations are that you're going to have to graph. For f of x, I want you to graph 2x plus 1 divided by x plus 1. Remember what this line means. This line means that the whole numerator is in a group and that the whole denominator is in your group. So if I'm punching this f of x into a graphing calculator, then I need to plug it in like this, 2x plus 1 in parentheses divided by the whole group of x plus 1. That's how I punch it in. I want you to practice all four graphs, punch them in, and then make your graphs, label any. Let me zoom out here a little bit so you can see which, there should be 4 functions up there. Label any asymptotes. Label any asymptotes. Don't forget which ones have x equals. Don't forget which ones have y equals. And then we're going to check for some understanding. Go ahead and try that. And then those of you who need time will go to the next video in a second.